Now, in this next example, on Maclaurin's theorem, use Maclaurin series to expand the function f of x is equals to x exponential 2x up to the term in x to power 4, isn't it? Hence, evaluate the integral from 0 to 1 of x f of x dx, isn't it? So the first thing we've been given here, before we even write the Maclaurin series, we've been given the function f of x, isn't it? So the function f of x will be given to be x exponential 2x. Are we together? Now, the first thing, for us to get up to the term in x to power 4, meaning we have to differentiate this up to the fourth derivative, isn't it? So if you differentiate it for the first time, what do you get? This is product rule, isn't it? If you have x exponential 2x, meaning this your x polynomial is u, exponential 2x is v, isn't it? So product rule, if you differentiate, you get u, v plus u, v. If this is v prime, the other one is u prime, isn't it? Are we together? Are we together? Yes. So if u is x, then it implies if you differentiate u prime, if you differentiate x, you get 1, isn't it? Are we together? If v is exponential 2x, then if you differentiate v, if you differentiate exponential 2x, it remains the way it is. Then you differentiate the inner function. If you differentiate 2x, you get 2. So it means when we differentiate this, we get u v prime. U is x times v prime is 2 exponential x, isn't it? So there we get, what do we have here? What do we have there? So if you multiply that, you have u, v times v prime, u is x, v prime is 2 exponential 2x. So x times exponential 2x, you have 2, x exponential 2x, then it is plus v prime, u prime v, isn't it? U prime is 1 times v is exponential 2, so it is just plus exponential 2x. Are we together there? So you see here, we have differentiated that for the first time. Then you are now differentiating it for the second time. You start. This first part, where you have 2x exponential 2x, remember, if you factorize this 2 outside, you have 2, in bracket you are differentiating x exponential 2x, isn't it? And if you differentiate x exponential 2x, you get the whole of this. What we found here? So we found that when you differentiate x exponential 2x, when we differentiate this term, we get the whole of this, isn't it? So here again, if you factorize this 2 outside, meaning if you want to differentiate x exponential 2x, you get the whole of this term again, isn't it? So it is 2 into 2x exponential 2x plus exponential 2x. So it means we differentiated this first part. Are we together there? Is that understood? Yes. Yeah, because when you factorize this 2 outside, you remain with x exponential 2x, and x exponential 2x is this, isn't it? If you differentiate it, you get the whole of this, which is this, isn't it? Then it is plus, you differentiate this term, isn't it? If you differentiate exponential 2x, you get 2 exponential 2x, isn't it? Are we together? So, can you open the bracket? We want now to simplify. F double prime of x, 2 times 2, 4x exponential 2x, isn't it? Then 2 times exponential 2x, you get 2 exponential 2x, then outside plus 2 exponential 2x, isn't it? Are we together? So we've simplified this. So after simplifying it, what have we found? We found it is 4x exponential, then 2x plus this, 2 exponential 2x plus 2 exponential 2x, you get 2x. Are we together there? See, we are done with that part. Okay? Then we go to the next one, we differentiate it for the third time. F double prime of x, isn't it? Now you have together. F double prime of, so F double, for us to get F triple prime. For us to get F triple prime of x, we means we differentiate F double prime, isn't it? So if we differentiate this term, see we factorize 4 outside. So if we factorize 4 outside, meaning we are differentiating x exponential 2x, isn't it? Are we together? And when the moment you are differentiating this x exponential 2x, what did you get? You got 2x exponential plus exponential 2x. When you differentiated x exponential 2x, you got the whole of this, isn't it? So it is times 4 which you factorize outside, isn't it? Are we together? Yeah, here we have 4x exponential 2x. If you have 4x exponential 2x, if you factor 4 outside, you remain with x exponential 2x, isn't it? So this x exponential 2x, the moment we were differentiating x exponential 2x, what did we get? We got the whole of this, meaning that is what we are going to get, isn't it? Are we together? Then it is plus 4 into, we are differentiating exponential 2x. So if you differentiate exponential 2x, you get 2 exponential 2x, isn't it? Are we together? Then you simplify this. What do you have? 4 times 2. That is 8x exponential 2x. 8x exponential 2x plus 4 times that. 4 exponential 2x plus 4 times 2. 8 exponential 2x, isn't it? So you come and record it here. F triple prime of x you found to be what? This is what you found. This, isn't it? You found it is 8xx exponential 2x plus 4 plus 8, because this exponential 2x exponential 2x, isn't it? So 4 plus 8, you have a total of 12 exponential 2x, because this term is the same as this term, have the same coefficient exponential 2x, isn't it? You join them together, isn't it? So there we've now found the f triple prime of x. The f triple prime of x. So we now look for the f fourth derivative of x, meaning we differentiate this for the fourth time, isn't it? Are we together? Yes. So when we are differentiating it for the fourth time, what do we have? This part, if you factorize 8 outside, meaning you are differentiating x exponential 2x. Are you seeing that? Yes. And when you differentiate x exponential 2x, what did you get? 2x exponential 2x plus exponential 2x. So it means you are done with this part, isn't it? You go to the other part. The other part we have plus 12. Then in bracket, what do we have? If you differentiate exponential 2x, what do you get? 2 exponential 2x, isn't it? Then you simplify as to record here, isn't it? Are we together? So this is 8 times 2 is 16x exponential 2x, we are done with that, isn't it? Then here, 8 exponential 2x, isn't it? Then this is 12 times 2, 24 exponential 2x. So 8 exponential 2x plus 24 exponential 2x, you have a total of 32 exponential 2x. So you've simplified it, isn't it? Are we together? Because this is 8 times exponential 2x, you get 8 exponential 2x, 12 times 2, you get plus 24 exponential 2x, you get a total of 32 exponential 2x, isn't it? So have you seen, we found all the derivatives, isn't it? But in Maclaurin series, what are we looking for? We are looking for these derivatives of 0, isn't it? So we don't want f of x, we want f of 0. We want f of 0, isn't it? So f of 0 in the Maclaurin series is at a point when a is equals to 0. And you know in Taylor series is at a point when x is equals to a. So x equals to a is equals to 0. So it means whether this x, when we put 0, we'll get f of 0, isn't it? Yeah. Are we together? So what is f of 0? So it is 0 because this x will be 0. See, 0 times anything, everything goes to 0. Are you seeing that? If you multiply 0 with anything, everything goes to 0. Because f of 0, meaning what they said, if you put 0, you have 0 times this exponential raised to power 0, which is 1. 0 times 1 is just 0, isn't it? Move to the next. F prime of 0. What is f prime of 0? You go to where f prime is, isn't it? So f prime of 0, it means what the x you put 0, isn't it? So it means this is going, when this x is 0, it means the whole of this time is going to be 0. Are you seeing that? Then we remain with exponential raised to power 0, isn't it? Anything raised to power 0 is 1. So it means we remain with 1 there. Are we together? You move to the next one, that is f double prime of. So where f double prime is here, isn't it? So where the x, if you put 0, what do you have? 0 times the whole of this term will go to 0, isn't it? Then here, 4 times exponential raised to power 0, anything raised to power 0 is 1. So 4 times 1 you remain with? Are we together? Yes. Then you move to the next one, f triple prime of 0, isn't it? F triple prime of? 0. Of 0. So what is f triple prime of 0? you go where f triple prime here, where the 6 you put 0. If you put 0 here, the whole of this term will go to 0, isn't it? Then exponential 0 is 1, so you have 12 times 1, isn't it? You remain with 12. Are you seeing that? Then f, the fourth derivative of 0, here. If you put 0 where this x is, what do you have? 0 times everything, the whole of this term goes to 0, isn't it? Then here you remain with 32 times exponential 0. Exponential 0, if the raised to 0 is 1. 32 times 1, you get 32. So as you see, we found all the f's of 0, isn't it? So after we found all this, we now go and get our Maclaurin series, isn't it? So we know that Maclaurin series of the function f of x, you start from f of a, isn't it? Are we together? You start from f of, so you start from f of a, meaning this is Taylor series first. Are we together? So instead of going to Taylor series whereby it's at a point when a is equals to 0, so it means in Maclaurin series we just go direct. Those who are just, I will just introducing those for explanation so that you get the whole concept, isn't it? Are we together? So Maclaurin series expansion of f of x at a point when a is equals to 0, meaning we start with f of 0, isn't it? Are we together? Then plus, when you differentiate it, you differentiate it for the first time, then what do? Look here. This is f of 0, then you differentiate it for the first time, you leave a space where we are going to put something, isn't it? Then you differentiate it for the second time, then you leave a space, then plus, you differentiate it for the third time, you leave a space, then plus, you differentiate it for the fourth time, you leave a space. So you see here, when you differentiate it once, it means you have x raised to power 1 over 1 factorial, isn't it? When you differentiate for the second time, it means you have x squared over 2. Are we together? It means you have x squared over 2 factorial. If you differentiate it for the third time, it means you have x cubed over 3 factorial. If you differentiate it for the fourth term, it means you have x to the power 4 over 4. Are you seeing the way it is easy to construct Maclaurin series? Maclaurin series is using the f's of zeros, isn't it? So if you want to expand f of x, you start from f of 0. Then you differentiate it once, you differentiate for second time, third time, fourth time. Meaning if you differentiate for the fourth time, is when we get our x raised to the power 4, isn't it? Are we together? So can you start substituting? What is f of x? F of x is x exponential 2x, that is f of x, isn't it? Is equals to what? F of 0, which is, what is your f of 0? It's 0, so it means this term is 0, isn't it? Then f prime of 0 is 1, so this is 1 times x divided by 1 factorial, so you just remain with x. Are we together? So you just remain with x. Then you move, we are done with this term, we are done with this, we go to that term. F double prime of 0 you found to be 4. So it is 4 divided by 2 factorial. 2 factorial is just 2, isn't it? So 4 divided by 2? 2. So 2 times x squared you get plus 2x squared. Are we together? Then you move to the next one. What is f triple prime of 0? F triple prime of 0 is 12. So this is 12. 12 divided by 3 factorial. 3 factorial is 6, isn't it? So 12 divided by 6 is 2. 2 times x cubed, you get positive plus 2x cubed, isn't it? We are done with that term. You go to the last term. What is f fourth derivative of 0? 30? 32. 32 over 4 factorial. What is 4 factorial? 24, isn't it? So 32 over 24. Just use calculator. 32 divided by 4 factorial. F fourth derivative of 0 is 32. 32 divided by 4 factorial. That is 4 over 3. Are you still working on it? What have you found? 4 over. So that is plus 4 over 3, then times x raised to the power 4. So have you seen? We found the expansion of the function f of x, isn't it? So what have we been told after getting this expansion? To evaluate the integral x f of x. So the first thing you come here, what is this? Your x exponential 2x is the function f of x, isn't it? So here you have your function f of x. So this one, for you not to confuse, if I just say the function f of x is equal to x exponential 2x, so that you don't confuse. So where there is x exponential 2x is the function f of x itself, isn't it? So what do we have here? See, we have x f of x. So what is x f of x? It means it is x times the function f of x. But the function f of x is the whole of this using the Maclaurin series, isn't it? Are we together? It is x times the function f of, and the function f of x, which is x exponential 2x, is what? Is the whole of this expansion we found, isn't it? So can you multiply x with the function, which is x plus 2x squared plus 2x cubed plus 4 over 3x to power x to power 4. Are we together there? So what do you get? You have x times x squared plus x times 2x squared, 2x cubed plus x times x cubed, 2x to power 4. Then x times the last term there you have 4 over 3 x to power 5. So you found the function f of x. Are we together? You found the function f of x. After finding that function, we now come, let me utilize this space here to use that function. The function f of x we found to be what? f of x we found is equals to x squared plus 2x cubed plus 2x to power 4 plus x to power 5. This is what we found, isn't it? But now you ask yourself, what do you want? You want the integral of f of x from 0 to 1, isn't it? So you simply introduce integral on both sides of the equation with respect to x. You simply introduce integral on both sides of the equation with respect to x. Then you put the limits you've been given is from 0 to 1. So it means when you are evaluating this integral, which is here, you are actually evaluating that integral. Are we together? Are we together? Is that understood? Good. So can we now start? X squared, if you integrate, you get x cubed over. Then here we have 2 is a constant. So x cubed, if you integrate, you get x raised to power 4 over 4. We are only dealing with the power only. Coefficient is not our business in integration, isn't it? Are we together? Move to the next one. Here we have 2 is a constant, then you move to x to power 4. X to power 4, if you integrate, you get x to power 5 over 5. Then here, 4 over 3 is a constant, then x to power 5, if you integrate, you get x to power 6 over 6, isn't it? So here we have 4 over 3, which was there, and x over 6. So 3 times 6 will give you what? 18, isn't it? Are we together? So it means this is a total of, it is over 18. Then you put your limits from 0 to 1. Then the answer will be upper limit minus lower limit. So you can see lower limit is 0, meaning when you put 0 where x is, the whole of that will just be 0, isn't it? Are we together? The upper limit is 1. So if you put 1 in the upper limit, what do you get to be the answer? Go to the calculator. When you put 1 at the upper limit, meaning 1 raised to power any power is 1, isn't it? Meaning 1 cubed is just 1, 1 raised to power 4 is just 1, 1 raised to power 5 is just 1, 1 raised to power 6 is just. So what are you doing here? You simply have 1 over 3 plus 2 over 4 plus 2 over 5 plus 4 by 18, isn't it? Because 1 raised to power anything is just 1. Are we together? So what do you get if you evaluate that upper limit? 1 over 3 plus 2 over 4 plus 2 over 5 plus 2 over 4 14 131 over 9. Into decimals, we have 131 over 9, isn't it? Which is the same as 1.456, isn't it? So 1.456 minus 0, you get the answer to be 1.4556. Are we together, ladies and gentlemen? So you see, as we are doing more examples, we are simplifying the theorem, isn't it? we are making it to be more simple, meaning we are trying to reduce those most steps we were using for explanation, isn't it? Are we together?
Yes.
Good.